What can be used to help solve the problem? A map showing a location, distance between location, type of transportation used. What features I need to solve the problem? Be able to calculate, be able to draw a map. This stage may include collecting and analyzing data from people who face the same problem. They could include interviewing people, sending out surveys, observing people. It can also include the use of sensors or GPS tracking. Step 2. Plan. Software engineers develop a plan for a solution of the problem. Planning can include making lists and drawing maps. As a proposed solution, plan should be very detailed. Step 3. Build. The code is written and the other part of the solution are added to the program. The build step ends when a working product is completed. Step 4. Test. Identify a problem by testing the source code or solution. Software engineers usually ask people to use the product and give feedback. There are different levels of testing. In the early stage, the programmer will learn test on their own. Then they will ask peers to test their solution. Later, the programmer will ask a group of users to test the solution and give feedback. Step 5. Improve. Fix problem and improve the solution. In this step, the bugs or other issues identified in the test step are corrected. Everyday engineering. Powerful technologies have become smaller, cheaper, and easier to work with, which means anyone can design and build amazing things with Lego, robotics, drones, 3D printer, desktop laser cutters, micro beads, Arduinos, and Mercuries. You can become an everyday engineer. Microbeats and Arduinos are very small computers or a single chip that can program do a number of different things, such as keep tracking of data, like a fitness tracker, or behave like a game controller. They be used to teach students coding and programming. Makis, a type of microcontroller like a microbit or Arduinos, are electronic invention kits for kids that allow the user to use alligator chips to connect everyday objects to computer programs. This allows the user to control the object in a different way. Chapter 7. Testing. Testing is an important part of the engineering process. As step 4 in the engineering design process, this task takes the most time. Many things can go wrong with the program. These are ways programmers try to limit the number of programs in their program so that they run smoothly. Defensive program. Defensive program is to design your program so that it keeps working even when things don't go as expected. One way to do this is to intentionally get your program to produce errors to see how you should solve them. For example, if you write a program where the user should input their email address, you could try to produce an error by entering text that is not an email address. Then ask, does the program still run correctly if a user input their phone number or name in the email address field? What can you do to prevent the user from inputting the wrong information? Use cases and test cases are the used in defensive program to help you see where adjustment may be needed in a program. Use cases. Use cases are a list of actions users can take. It describes how users will use your program. The list could be very detailed flow chart, or it could be flow ideas you come up with. It's important that the user is able to run a program without errors. For example, after you complete the programming of the game, you should play the game from beginning to end to make sure it runs the way you want it to. Test case. Use case test check to see if the users can complete the goal in the program for every use case. There will be many more test cases. Test cases are specific, more detailed tests. They use conditions that your program may run under. The use case is used to define the functionality required. Use case testing is then testing for that functionality. Test case focus on one condition is variable at a time to make sure the program works in all situations. For example, if you are creating a video game, you should create a test case that makes sure your character jumps when you press the spacebar. In the test passage, you should also test to see what happens if you hold down the spacebar instead of pressing it just once. Programming defensively would mean making sure that no matter how long the user held down the spacebar, the character would jump just once. If you defensively program your game, then your character will just jump once. If you didn't defensively program or forget to test what happened when the users hold down the spacebar, the character might be something you don't want them to do. Another example, if you program the calculator app that divides your number by 10, just in case make sure your program works with different type of numbers, would be program crash if the user tries to enter 1 or 0. It's important to pick test case that use many types of input. For example, for a calculator app, instead of testing only the digit 0 to 9, choose positive and negative integers, rational numbers, and 0. Remember from math class, positive integer, a whole number greater than 0, not a fraction or a decimal. For example, 2, 5, 9, 50. Negative integer, a whole number less than 0, not a fraction or a decimal. For example, minus 1, minus 5, minus 150. Rational number, a number that can be written as a fraction or a ratio. For example, minus 5 can be written as minus 5 for 1, and 2.15 can be written as 215 for 100. Chapter 8. Documenting. Documentation is information about programs code. There are two main types of documentation: command and README file. Command. All programming languages have a way to add command to the code. Commands are not part of the program. They are skipped when the program runs and can't be seen by the user. Commands are messages written by the programmer about the programmed code. They can be explains about what a chunk of code does, reminds about things to add or change in the code, or question to other programmers who will look at the code. Example, add a countdown clock at the top of the screen. Commenting on code helps you remember what each section does. This is helpful for large programs because you won't remember what every line of the code was written to do. Comments also are helpful for short programs because you might want to look at the code long after you finish rewriting. Sometimes you will want to reuse code for another program, or code you or someone else wrote. Comments help you quickly find the portion of code you want to reuse. For example, if you were making a game, instead of creating the code to move characters around your own, you could copy a similar chunk of code from another program. You could write the command so that you know which chunk of code this is in your program. Comments are also used to help debug a program because comments are not read when the program is run. Commenting out the selection of code is an easy way to make the computer skip lines of code that may contain a bug without deleting them. Commenting out. Marking selection of code as a comment so that it will not be run with the rest of the code. Comments can also help in debugging by editing test line of code that you comment out when you are done testing it. Comment can also note by yourself as you code. For example, you could leave show note as a reminder to yourself like bug or fix me, a knowing bug that you want to come back to do. The note that what code you need to write but need to come back to later. README. A README file usually typed in all caps to get your attention gives you information about the program, including which files are included, how to install it, how to use it, credit and attribution or known bugs. A README file can be written for the user, other programmers, or both. Usually only one README file is used for program and usually is a plain text file. Plain text file a text document that has no formatting like bold type, intent, and paragraph spacing. Just word and punctuation. Although README file can include user information, a user guide is a more common way to help users figure out how to use a program. Usually, user guides are only created for large, complicated programs like Microsoft Word or Excel.